Guys, in this video we're going to keep talking about the backward solve, and basically what we're going to do in each video is we're going to add the backward solve functionality for each of the solvers or modules that we developed so far. The first one I want to talk about is the IKFK module. We can see not much needs to happen in the solver IK nor the solver FK, and I'm going to explain why. A bit of manipulation needs to happen in the solver IK and FK, the one where I'm combining both, but that would be pretty much it. So today we're going to see how to backward solve the solver IK FK. In order to demonstrate that, what I've done, again, I have trying to simulate a motion capture input or any kind of animation. So I opened in Maya this skeleton. This is just, there's no rig, this is just joints and geometry. And I have animated the arm because the solver IKFK, it's being used by the module arm and the module leg. So for now, I'm just animating one arm. So this is the motion, and literally this is just animation on bones. All right. So this is the kind of motion I'm doing. The reason why I did this motion is because it's going up, it's folding the arm so I can check the ball vector position. It's going forward, preserving the rotation of the elbow just to check the ball vector position, and then going back to the original. Okay, so this is the animation. What I've done here is that I've exported the animation and brought it back into Unreal as an animation clip. So far, nothing really fancy. So here we have the animation, and it should stop around 40. Yeah, so 40 is the last frame, and the last frame is the same as the first frame. Okay, so remember, backward solving, now that we have this animation as an input, we would love to have this animation, but rather being on bones, coming from motion capture or any kind of input that you want, procedural animation, whatever you can turn into an animation clip in an animation sequence in Unreal. So now that we have this, we would love to have this animation, but rather than express as bone rotation, but rather as controls. So in order to do that, we need to start implementing backward solving. So let's try and do let's have a look at the final result. So in here, let me drag and drop, not the control rig. I'm going to drag and drop my simple skeletal mesh. And then, so let me zero that out, and let me zero this out. Great. So now I want to create a level sequence. Let's create it inside here. Level sequence. My level sequence, let me save it. I'm going to take the skeletal mesh and apply it. So now I have a slot in my level sequence that is dedicated to the skeletal mesh. In the animation, I'm going to apply the left arm, and this basically allows us to see the animation on a timeline. Nothing fancy. Now, because I have already implemented in Control Rig the functionality, what I can do now is that I can click on Control Rig, bake to Control Rig. We saw this in the previous video. Right click on the skeletal mesh, bake to Control Rig, skeletal mesh Control Rig. I'm not care about reducing any keys because I want the full animation. And here we go. So what we have now is the animation on the control rig, and you can see that the FK controls of the arm are now being animated. Because I've implemented the function in the IKFK module, it should be possible to see the same animation but performed in IK. So let me find the setting, because right now the setting that sets the arm to FK is being fully animated as well. So if I open this one here, left arm IKFK, so basically this is now set to be FK all the time. So let me get rid of them up to frame 60. So right now it's still in FK. But in here, I want to switch this to IK. So you see the arm is switched. And you can see that the same animation is performed, but on the IK controls. So when let me turn this off. You can see that not only we are able to bake down pre-made animation by a DCC application and by mocap, we can also have, because we implemented IK-FK switching in the module, when we bake it down, we can have the arm being in IK when it's convenient for us and then switch to FK with no loss of animation. So how is this done? Well, as I said, we're going to take a look at the IK-FK solver for today. So let me open control brick. So again, because I'm gonna implement this in the solver IK-FK, then all the work that we're gonna have to do in the next video will be to add this functionality at the higher level module. So today I'm gonna just touch solvers. The first solver I'm gonna touch is solver FK-AK, and then we're gonna have to implement additional functionalities in the module arm and the module leg. But hopefully it's always going to be the same thing. So hopefully this is gonna open. Unless I had it already. And so yeah, and the most complicated thing would be when we get to the spline and the spline IK, because inverting a spline IK can be problematic. There we go. Wait. Okay, this is our rig graph. This is exactly the same. Setup mode, forward solve. Let's have a look at what I've implemented in the backward solve. And as you know, backward solve is the third type of solver or event that you can have in the rig graph. Backward solve. For now, I've only drag and dropped the solver IK-FK, and I populated the values with the left arm. So, but at the very end, I only have backwards ticked on. So, let's remember a little bit what was happening in the solver IK-FK. Am I in setup mode? I'm using the solver IK in setup mode and the solver FK in setup mode. And what this does is snaps the controls. We saw this many times. Then, additionally, before this node that I just added was there, additionally, if we were not in setup mode, we were always checking, are we in IK or are we in FK? If we are in IK, then I'm running the solver IK in normal mode, like in forward solve, and the solver FK in follow mode. So this would allow us to switch between solver IK and FK, because when solver IK is computing, the controls are moving the bones of the solver IK, and the bones that are being solved by the IK controls are moving the FK controls. So we already have a way for us in the solver IK to follow the bones. If I run solver FK in follow mode, the solver FK controls follow whatever happens to the bones that are specified in bones. And these controls will follow everything that is happening in bones in follow mode. So if we are in IK, the IK controls are driving the bones, which are driving the FK controls. If we are not in IK mode, it means that we are in FK, and it's exactly the opposite. So solver FK, not in follow mode, is now driving the IK bones in follow mode. So the controls in FK are moving the bones, and the bones are moving the solver IK in follow mode. FK controls move bones, bones moves IK. Okay, so these two things are exactly the opposite. So these two graphs, you can see this node is this node, this node is this node, but with the option follow, reversed. Okay? So the cool thing about having implemented solver FK and solver IK in this mode is that for us, in order to implement the backward solve, which is nothing else, we want all the controls to always follow the bounds. Doesn't matter if we are in IK or FK, right? So because we already implemented the follow mode, in order to add the backward solve functionality in the solver IK FK, the only thing you need to know is, has the user ticked on the backward solver mode? If false, then we do this classic, what we just described. If it's true, if we are in backwards mode, then the only thing I need to do is having both solver FK and solver IK in follow mode. So now, no matter what happens to the bones, FK controls and IK controls are following. Okay? So then in the rig graph, I can simply drag and drop the solver IK FK, populate the values, and tick on backwards. Basically, the only thing that this graph does is checking these values here, going to the graph solver IK FK, checking, are we in setup node? No. Are we in backward modes? Yes. Then simply connect all the controls in FK to the bones, and all the controls in solver IK to the bones. This basically is the very first implementation of the backward solve, and that's pretty much what I've done. There is nothing else. This basically allows us to convert this animation. Where is it? Here. Do I have this open already? Yes. There it is. Sorry. So this basically, when I run this function, let's look at this again. Let me get rid of that. Let me turn on this animation back on, active. So this is pure bone animation, can be your mockup, can be anything. When I right click here and say bake to control rig and I click here, the system will basically run this portion of the graph. And this portion of the graph only. And by following the logic that is implemented here, now the logic is saying everything that is related to the left arm, all the controls that are involved, follow the bones. So per frame, we say bake to control rig. I want to evaluate it per frame, bake to control rig, boom. Now the controls are fully following. Now why this is happening, there is an offset, it's because I should have started from the very beginning. It's my bad. But that's pretty much the case. Let me fix that real quick. So let's go back to 0. Yeah, and there it is. Not this one. The green line, but this one. Okay. So this is it. I'm hoping this video makes sense. Now we're gonna start moving this functionality a little bit above. In order to do that, we need to change the arm module, the hand module, and then with that in mind, if I change the hand module and the leg, then basically we have all the body. The only thing that are left are the spine and the head, and then the eyes. Yes, and the spine will take a little bit longer because it's a bit more complex when it comes to the spine. Okay, see ya.